Hello everyone, welcome back to my YouTube channel. In this video, I want to solve past paper from EJU Mathematics 2018, second session, course 1, question from part 4. This is basically the last question from this past paper. If you want to watch the solution from the other problem on this paper, you can check link on the description box below, or you can also check my EJU playlist if you want to watch the solution from the other paper. And I hope that playlist will help your EJU preparation. Okay, before we start, don't forget to hit the like button, share my video to your friend, and don't forget to subscribe my YouTube channel if this video help your study. Okay, in this question, we have a quadrangle ABCD be a rhombus. Basically, we have a quadrilateral ABCD, and ABCD is a rhombus where the length of sides is square root of 2. As you know, rhombus has 4 sides of equal length. In this case, the length is square root of 2, and angle ABC is 30 degrees. So, if I illustrate it, I will have a rhombus like this. Assume this is a rhombus of equal sides, which is square root of 2. And then angle ABC, ABCD, angle of ABC here is 30 degrees. We have AC equals to blah 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 and BD equals to blah blah blah. So we need to find AC, which is the first diagonal of the rhombus, and then later we will find BD, which is the second diagonal of the rhombus. If you want to find the first diagonal of rhombus, you can use a cosine rule. Since we already know this is 30 degrees, and then AB is equals to BC, which is square root of 2. By using a cosine rule, you can find AC squared. If I use a cosine rule, I have AC squared is equals to BA squared plus BC squared minus 2 times BA times BC cos 30 degrees. BA squared is square root of 2 being squared, I have 2. BC squared is also 2 minus 2 times BA times BC. BA is square root of 2 and BC is square root of 2. So BA times BC is equals to 2. So 2 plus 2 minus 2 times 2 cos 30 is equals to half square root of 3. If you simplify it, I can cancel out 2 here. That means I will obtain AC squared is equals to 4. 2 plus 2 is equals to 4 minus 2 square root of 3. So ABC here is 4, 2, and 3. And then, if you want to find BD squared, you can also use a cosine rule. But now, I think you need to focus on triangle either BAD or BCD because you want to find BD. Since ABC is 30 degrees and AB is parallel to CD, then angle BCD is equals to 150 degrees. This is what we call a corresponding angle. As you know, corresponding angles are supplementary. That means they are add up to 180 degrees. So, since ABC is 30 degrees, I know that BCD is 150 degrees. This is 150 degrees. And then once again, by using a cosine rule, you applied the cosine rule to this triangle, you can find BD squared. So by using cosine rule, BD squared is equals to CB squared plus CD squared minus 2 times CB times CD cosine 150 degree. CB squared is equals to 2, CD squared is also equals to 2, minus 2 times CB times CD is equals to 2, square root of 2 times square root of 2, yeah, times cosine 150 degree. Cosine 150 degree is equals to negative half square root of 3. You can cancel out 2 here, and then minus times negative sign here becomes plus. So my final answer for BD squared is 4 plus 2 square root of 3. So DEF is 4, 2, and 3. Next, now for any positive numbers a and b, we have square root of a plus minus square root of b is equals to a plus b plus minus 2 square root of ab. Using this formula, we obtain AC equals to blah 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 and BD is equals to blah blah blah. I have AC squared here. AC squared is 4 minus 2 square root of 3. So I will write it down once again. AC squared is equals to 4 minus 2 square root of 3. If I convert or manipulate this form into this one, I can write down AC squared is equals to 1 plus 3 minus 2 square root of 1 times 3. Or I can say that this one, you can see, this form is already equal to this form. 1 plus 3 plus minus, in this case I use the minus sign, 2 square root of 1 times 3. So I can write down this into square root of a plus minus square root of b squared. I will use the negative sign because my sign here is negative. So I will get square root of 1 minus square root of 3 squared. Square root of 3 squared. From this form, you can convert it into that form. But you need to remember or be careful. I think I will change the value of a and b. Because if you see this form, you can see that my number or my result here is negative. Square root of 1 minus square root of 3 is a negative number. So to be safe, I think I will manipulate it into, instead of 1 plus 3, I will manipulate it into 3 plus 1 minus 2 times 3 plus 1. Just to be safe. And then I can write down as square root of 3 minus square root of 1 square is equals to AC squared. That means AC, you can cancel out the squared here. Then you will get AC is square root of 3 minus square root of 1, which is square root of 3 minus 1. So G is equals to 3 and H equals to 1. By using the very similar concept, you can find BD. My BD is 4 plus 2 square root of 3. BD squared is equals to 4 plus 2 square root of 3. I think you can do it by yourself. The difference between AC squared and BD squared only its sign. So I think you can try to do it by yourself. Then my BD is equals to square root of 3 plus 1. So I is also 3, J is 1. Okay, let's move to the next page. Let us draw 4 circles, each centered on one vertex of rhombus ABCD. So now I will draw a circle on each vertex of the rhombus with the following condition. So as you can see here, this is your rhombus ABCD. Angle ABC is 30 degrees as mentioned earlier in this question. The radii of the circles centered on vertices A and C are length R. So this is R, this is also R. The length of this small circle is R. And then the length of circle on vertices B and D has radius square root of 2 minus R. Makes sense, yeah? Because your rhombus has length of side square root of 2. Remember on our previous question. Since this length is R, that means the radius of this larger circle is square root of 2 minus R. Square root of 2 minus R. Circles centered on opposite vertices may touch each other but may not intersect. So if you see here, this circle and this circle may touch each other but may not intersect. Let us denote the area of the region common to rhombus ABCD and these 4 circles by S. We have S equals to blah blah blah. So we need to find the common region or the area of the common region between the rhombus and the circle. So basically you need to find area of these sectors. Area of these sectors. To find the area of these sectors, I can find the area of this first sector and then I will multiply it by 2 and then I will find the area of this sector and also I will multiply it by 2. So I will find the area of this sector first. I will denote it as A1. The area of A1 is equals to find the area of sector, we can use this angle which is 30 degree over 360 degree, the area of this whole circle, times the area of one full circle which is pi times radius square root of 2 minus R squared. If I simplify it, I will obtain 30 divided by 360. I got 1 over 12 pi, and then I think I need to expand this. I will get 2 minus 2, 1 over 12, yeah? This is 1 over 12, not 1 over 2. Let me write down it once again. 1 over 12 pi And then if you expand this, 2 minus 2 square root of 2r plus r squared. I will move it into here, I think. And then I will leave it first. I do not want to simplify it first, so leave it here. And then I will find A2. Basically, A2 is the area of this small sector. As you know, angle BAC is 150 degrees because angle ABC is 30 degrees. So, to find A2, I can use the same equation, but my angle is 150 degree over 360 degree times pi times the radius of the circle, in this case is r, times r squared. If you simplify 150 divided by 360, you will get 5 over 12 pi r squared. We will add A1 and A2, and then at the end, don't forget 2 times by 2. Because I just calculate, now I only calculate A1 and A2. I haven't calculated this region and this one. So I will add them first. A1 plus A2 is equals to 1 over 12 pi 2 minus 2 square root of 2r plus r squared plus 5 over 12 pi r squared. If you see here, we will factorize pi only. So I think I will times it by 2 first, and then at the end I will factorize the pi. So area total is 2 times 1 over 12 pi 2 minus 2 square root of 2r plus r squared plus 5 over 12 pi r squared, and then you can distribute or expand 2 here. You will get 1 over 6 pi 2 minus 2 square root of 2r plus r squared plus 5 over 6 pi r squared. And then my last step is I will expand or distribute 1 over 6 into the brackets. Then I will get, I will write down here, yeah. I will get pi 2 over 6 minus 2 square root of 2 over 6r plus 1 over 6r squared plus pi times 5 over 6r squared. I just change the position here. And then after that, I can factorize pi. So I will get pi, open a large bracket, 2 over 6, which is 1 over 3, minus 2 square root of 2 over 6, which is square root of 2 over 6 over 3 r plus 1 over 6 r squared plus 5 over 6 r squared, because I already factorized the pi. Then the area total, or the total area, which is denoted by S, is equals to pi 1 over 6r squared plus 5 over 6r squared, you obtain r squared, minus square root of 2 over 3r, this one, yeah, and then plus 1 over 3. This is our S, which is the area of the common region of the rhombus and those 4 circles. That means K is equals to 2, L is equals to 3, M is equals to 1, and N is equals to 3. Where the range of R is blah blah blah. They ask to find the range of R. Don't forget we have one condition here, that is the circles centered on opposite vertices may not intersect. And as you remember, we already find the length of AC and BC. The length of AC is square root of 3 minus 1. That means R, this is the radius of the small circle, plus R, this is the radius of the small circle, which is 2R, must less than AC. 2R must be less than AC. Because if 2R greater than AC, that means these two circles will intersect each other. So my first condition is 2R, I will write down here, yeah, 2R must be less than or equals to AC. AC is square root of 3 minus 1, so 2R must less than or equals to square root of 3 minus 1. Let me check once again, okay. Then R must less than or equals to square root of 3 minus 2, sorry, square root of 3 over 2 minus 1 over 2. And then of course the second condition is the radius of this large circle plus the radius of this large circle must also less than or equals to BD. We already find BD. BD is square root of 3 plus 1. So 2 times the radius of the large circle, which is square root of 2 minus R, must less than or equals to square root of 3 plus 1. This is BD, yeah? And then you can divide all the terms by 2. You will get square root of 2 minus R less than or equals to square root of 3 over 2 plus 1 over 2. And then you can isolate R. Move R to the right hand side and then the other expression to the left hand side. Then you will obtain square root of 2 minus square root of 3 over 2 minus half less than or equals to R. So R must be greater than this but less than this. This is the range of value of R. I will copy it first. Then I think we can find the answer for letter O until U. You can see here R must be less than or equals to this. So S is 3, T is 1, U is 2. You can express it into single fraction. So S is 3, T is 1, U is 2. And then for this one, you can express it into single fraction. So R must greater than or equals to this one. So O, P, Q, and R is 2, 3, 1, and 2. That is the range of R. Hence, S is the common region or the area of the common region is minimized when R is equals to blah blah blah. We need to find the minimum value, we need to find the value of R where S is minimized. Since we want to find the minimize of S, that means S prime is equals to 0. we need to differentiate s. If you differentiate it, since pi is a constant, we do not need to differentiate it because pi is a constant that we multiply with our variable. So just derive this expression. The derivative of r square is 2r. The derivative of square root of 2 the derivative of square root of 2 over 3r is square root of 2 over 3. And then the derivative of 1 over 3 is 0. So this one equals to 0. You can divide the constant here to the other side. Then I will get 2r is equals to square root of 2 over 3. Therefore r is equals to square root of 2 over 6. That's the value of r. And the value of s then is blah blah blah. After you get r, you need to find s. Simply put your r into this equation. If you substitute your r into this equation, then you will get s equals to pi 2 over 36 minus 2 over 18 plus 1 over 3. I can change the denominator by 36. Then I will get 12 over 36 here. 12 minus 2 is 10 over 36 pi. And if you divide it by 2, you will get 5 over 18 pi. This is for x, y, and z. And this is also the end of this video. Thank you very much guys for watching this video till the end. I really hope I can see you guys on my next video. Bye bye.